Hello folks, we are once again back with the miscellaneous exercise. It's the next problem that we are supposed to be doing. This is the problem number 15. Now the problem number 15 is a repeated problem from the earlier exercise. We have done an identical problem in the earlier exercise, problem number 23 or so. From the earlier exercise, it's exactly identical except for the r's. The capital R is converted into small r over here and so on, but the concept is exactly the same since it's there in the exercise, so we'll be doing it. And all the exercises that we are doing is with reference to the old textbook. The new textbook with lot of deleted portions, question won't be matching. You'll have to look at the question in order to tally up with the content. So let's go through the question. It's the problem number 15. As I said, it says that show that the altitude of the right circular cone of maximum volume, so you have to show that volume is maximum, that can be inscribed in a sphere of radius small r is 4r over 3. So actually you have to do two things. You have to show that the volume is maximum and you have to show that the height is 4r over 3. So those two things you have to do. So let's get started right away. As I've done something in the figure and shown that the circle, this cone is sitting inside a circle whose radius is smaller, and we are taking the cone whose height is h and capital R is the radius. So all this we will introduce and then right away, because we know we have to get the volume, we can work right away with it. So let maybe h and R be the height and radius of the required cone. Yeah, and it's there in the figure as shown in the figure. And then so we foresee it that when we take the volume is what they have asked us to show. Volume is pi over 3 r squared h. There we are going to encounter this double variable problem, so automatically we'll have to convert one in terms of the other. For that you require to have something known, and that you're going to get from this right triangle OAB, as what we had done in the previous question. So in right triangle OAB, what do we get? We get actually OA squared plus AB squared equal to OB squared. OA squared plus AB squared equal to OB squared. Why we got it? We got it by Pythagoras theorem. Now it's very clear to us that OA is actually this entire length is h, and this radius of the circle is r, so this much part is r. So it is going to be OA is going to be h minus r, the whole squared, and AB is going to be capital R squared and OB is going to be R squared. Let's expand this. H squared minus 2HR plus R squared equal to R squared. Only these two can cut. Now we know that volume is going to be pi over 3 r squared h. You can easily substitute the r squared. So let's take these things on the other side so that that substitution will be comfortable for you. So it will become r squared equal to 2hr, because it's going on the opposite side, minus h squared, relation number 1. And without wasting any time, since we know that we have to find the volume, let's write the volume as pi over 3 r squared h. And in that r squared, we've got it quickly substituted, 2hr minus h squared from 1. Now what we are going to do, we'll open the bracket so that we will have 2rx squared minus h cubed. So quite finished product for you, because you can take the first derivative, because the entire volume is in terms of the single variable h. So you can go in for the first derivative, second derivative, and so on. So let's take the first derivative now. dv over dh. What is it? Pi over 3. Derivative of h squared is 2h and derivative of h cube is 3h squared. So it's going to be pi over 3 4rh minus 3h squared, and then since we require the second derivative, quickly find the second derivative, which is going to be pi over 3 4r, h has got derivative 1 and h squared has got derivative 2h, so 6h, second derivative. Now we know that we need to find the critical point, so for that let's make dv over dh 0. So that's pi over 3 times 4rh minus 3h squared. See, h is a non-zero quantity. It's very clear to us that h is a non-zero quantity, and so you can take the h out, and you can divide throughout by pi over 3h, so that this fully gets eliminated. Or actually, h cannot be 0. Actually, that's the reason. So you can eliminate like that, and therefore you will get 4r minus 3h equal to 0, which will mean r h is equal to 4r over 3. This is one thing that they had asked us to show. Now we have to check for the maximum and minimum, so or minimum. So d squared v over dh squared at this point, at h as 4r over 3. So what will happen? Pi over 3, 4r outside, 6h. h is 4r over 3. So that is 2. So 8r, obviously negative. So maxima occurs. Hence proved. Because they asked us to show that height is this way, and they have asked us to show that the maximum volume happens. I'll just check if we have left anything. Show that the altitude is this and inscribed is this. Perfect. Hence proved. That's for our problem number 15. And with the problem number 16, we can meet in the next video. Thank you.